Hello, welcome to our lesson on application of differentiation, and today we are going to look at rate of change. So with the rate of change, we are going to look at how when we have two quantities, how one of the quantities changes with respect to the other. Alright, so let's say if y changes with respect to x, then I can write this as dy on what? Dx. It means that y has changed with respect to what? With respect to x. So if somebody also writes dv on, let's say, the r, it means that v has changed with respect to what? With respect to r. v has changed with respect to r. And sometimes with this, let's say I'm giving v in terms of r, so v is equal to 4/3 pi r cubed. So if I want to find the rate at which v changes with respect to the r, then that will be dv on what? The r. And then my 3 will come into 4/3 times 3. That will be 4 pi r, and I'll subtract 1 from here. Take note that the pi is what? Is constant. Alright, so most of the time with the rate of change, mostly we look at plane figures, how one side of the plane figure changes with respect to maybe its volume or its what? Its radius. Alright, so let's look at some example. And before that, when one quantity changes with respect to the other, it can be increase or what? Or decrease. Okay, so if there is increase, then it means that you are going to have a positive value. If there is decrease, then it means that the rate of change will be what? Will be a negative value. Alright, so let's look at some examples here. So you can be given that if the radius of a circle is 2 centimeters, okay, at what rate is the area increasing with respect to what? The radius. Alright, at what rate the area increasing with respect to what? With respect to the radius. So we are finding the rate at which the area is increasing with respect to the radius. So area, that we are finding the rate at which the area is increasing with respect to what? The radius. So the rate of change of the area to the radius. And then what is the area of, he's talking about a circle, so that is pi r squared. Then you can say the r on the a on, so you can say the a on the r. Okay, you are finding the rate of change, the area increase in respect to the radius will become 2 pi r. So note that the pi is constant, so 2 can be subtract 1 from here. Alright, so you get 2 pi r. And then we're giving the r as 2. So you have 2 pi multiplying 2, and then there are 4 pi. Okay, 4 pi. So the area is what? The area is centimeters per centimeter. Alright, so the area is increasing 4 pi centimeter squared per centimeter. Alright, the rate at which the area is increasing. The area, okay, area is centimeter squared, but it is increasing with respect to radius, and the radius is centimeter. So you can say 4 pi centimeter squared per centimeter, area per the radius. Alright, then let's look at number 2. If the side of a cube is 5 centimeters, at what rate is the volume decreasing with respect to the side? The volume decreasing with respect to what? The side. So he's talking about volume. So you have the volume with respect to what? The side. So let's say the side is L. Okay, so you are going to find the V on the L. Alright, if that is the case, then you have to find the volume of what? Of a cube, which is L cubed. Then my V on the L is going to be 3L squared. 3L squared. Okay. Therefore, my side, what is the side given? 5 centimeters. That will be 5 squared. So 3 times 5 squared. And that will give us what? 75. So 75, you can say 75 cube. So centimeter cube per centimeter. all right, centimeter cube per centimeter. Okay, so this is the rate at which actually the volume decreases with respect to time, but because it is decreased, then you attach negative to show that there is what? There is a decrease. If there is an increase, it's positive. If there is a decrease, it is what's negative. Okay, so you attach it to show that there is what? There is a decrease. All right. So these are some of the few examples we can give. You can also look at the rate of change with respect to what? Time. So let's go and look at the rate of change also with respect to time and how you also do that one. All right. Okay, so as you said, we are also going to look at the rate of change with respect to what? With respect to time. Okay, so if the rate of change is with respect to time, how it is being done. So if the changes with respect to time, okay, as the time is t, then I can say this what? Dv on what? dt. Alright. And even sometimes you since it is the change is respect to time, then what will happen is that you may be given the unit also in time, mostly in seconds. Alright, mostly in seconds. So if it is volume, whatever it is, maybe centimeter, can be centimeter cube per second. Alright. It can be meter cube per second, and so on. That means there is a rate of change respect to what? Respect to time. Okay, so here you can be asked like the volume, let's say, of a cube, okay, increases at the rate of, let me say, 20 centimeter cube per second. That's the volume of a cube. That is dv the what? dt. Okay, dv dt. So volume of a cube increases maybe with respect to time as 20 centimeter cube per second. Then we can say this is what? dv on dt, because it's the increase with respect to time. Maybe you can also the volume of a sphere increase with respect to time, and you can also give you. So what you should know that the unit is very, very important. Okay, if the unit is centimeter cube or can meter cube and so on, or if the unit is per second or per time, minute, whatever it is, then it means that you are differentiating with respect to what? With respect to time. With respect to time. So you can be given, maybe if it's a plane figure, okay, as I was saying here, the volume with respect to time, and you can be asked to find the radius also with respect to what? With respect to the same time. Okay, at what rate is the radius also going to increase with respect to the time? If let's say the volume is increasing at a certain rate per second, at what rate is the radius also going to increase? Okay, exactly. So with this, okay, what we can do is what we can do is to apply what? The chain rule. Okay, normally the chain rule is being applied here to solve questions like this. All right, so remember that the chain rule, maybe I'm giving y is equal to maybe 2x plus 3 exponent, let's say 5, and what you do is to what? To represent the function here by a variable. Maybe let u be equal to 2x plus 3. So that means my y will be equal to what? U exponent 5, because u is 2x plus 3, so my y is going to be u exponent 5. So if I'm differentiating this function, then my dy on the x, okay, will be that I will differentiate this, okay, the u with respect to what? X, and multiply by the differentiation of the y with respect to what? The u. So if I differentiate with respect to, become what? Dy on du. Then I differentiate the u with respect to x, and that'll be what? Du on what? Dx. So the function, okay, y is in terms of what? X. Okay, and then x is the u is also in terms of what? Also in terms of what? In terms of x. Alright, so you find the differentiation of what? The differentiation of u with respect to x and multiply by y respect to what to u. So this is the same, this is the chain rule approach that we are going to apply in solving question what with the rate of change with respect to what, with respect to time. So let's look at some few questions and then we know how to do it. All right. Okay, so let's look at the examples where we are given the rate of change in terms of what? In terms of time. It said the side of a cube is increasing at the rate of 6 centimeter per second. The side of a cube is increasing at the rate of 6 centimeter per second. So here it's talking about the side of a cube increasing with respect to time per second. So if the side of the cube is, let's say, L, then this will be the L on what? The T. Okay, the L on the T. And that is what? 6 centimeters per second. Okay, because we are giving the rate of increase with respect to time. So the side of a cube is increased, so the side. So if let's say the side is L, then it is increasing at the rate of 6 centimeters per second. So the L, the T is 6 centimeters per second. Find the rate of increase of the volume when the length of the side is 9 centimeters. So you have to know here the side is increasing at the rate of 6 centimeters per second. That is with respect to time. So it means that as we are finding the volume, okay, the increase in the volume then of the cube, then we are also going to find the increase in the volume with respect to what? With respect to the same time. All right. But the side is increasing 6 centimeters per second, and we are finding the corresponding increase in the volume. Okay, if the length of the side that increase at the rate of 6 centimeters per second is 9 centimeters. So if I'm finding the rate of increase in the volume with respect to the same time, that will be dv on what? dt. And I'm doing that because the length increase with respect to time. So I'm finding the rate of increase of the volume also with respect to a time. That will be dv on dt. Okay, and look here. Here is very, very important to understand the rate of change with respect to time. All right. So if I'm finding dv on dt, then if I look at the question, okay, what was I given? I was given what? The length of the side of the key, which I said it should be L. So if I'm finding dv on the t, then I'm going to find dv with respect to what? With respect to what I am given in the question, which is what? The length of what? Of the key with respect to L, the L. All right. So I'll find the volume with respect to what? The change in the volume. How the volume has changed with respect to its side, that is the L. Then I'll multiply. The moment you are able to write this, then what is left is simple. So what is going to that? Then when you are multiplying, then your L is going to come here. Okay, you multiply by the rate of change of the side of the key with respect to what? With respect to time. All right, with respect to time. Okay, so the volume with respect to its length, okay, times the length with respect to what? With respect to the time. And this is so simple. So the volume with respect to the length, then you see whatever you write here will come here. Okay, then the denominator here will also be here. So when this even cancels, we have dv on dt. So when you are finding the volume with respect to time, then you have to find the volume with respect to its length, and then the length too with respect to the time, and that will give you the volume with respect to time. Okay, so the length with respect to time is 6 centimeters per second. All right, okay, that is clear. Then what we have to now find the volume with respect to what? The length. Okay, so we have to quote the volume formula. Volume of what? A cube. We are talking about cube. Is what? L cube. Then dv on the L. The volume with respect to what? The side. Okay, will give us what? 3L square. So my dv on the L is giving me 3L square. So therefore, the rate of increase in the volume with respect to the time is equal to the V on the L, which is 3L squared, times the L on the T, which is what? 6 centimeter per second. Alright, so the rate of change in the volume, you find the rate of change of the volume with its length times the rate of change of the length also to the time. Okay, so the rate of change of the volume with respect to time, you find the rate of change of the volume to its length, okay, because the length that change multiplied by the rate of change of the length also to the time. All right, so what are we going to have here? We have 3. We are giving the length as what? The length of the side as 9. So times 9 squared times 6. So you put this on the calculator and then you get your answer. So 3 by 9 squared times 6. So 3 by 9 squared times 6 will give us what? Will give us 1458, alright, centimeter cubed per second. So it is volume to time, so centimeter cube per second, centimeter cube per second. So this will be the rate of change of the volume to the time if the side of the length what also changes by 6 centimeter per second. Alright, let's go to the next question. Okay, so let's look at number 2. Number 2, a spherical balloon volume increases at the rate of 15 centimeter per second. Find the rate of increase in the radius when it is 10 centimeters. Okay, so now you have to look for 15. What is the rate of change per time here? A spherical balloon volume increases at the rate of 15 centimeter cube per second. So the volume of the cube, okay, increases at the rate of what? 15 centimeter cube per second. So the volume with respect to time is what? 15 centimeter cube per second. Because a spherical balloon volume increases at the rate of 15 centimeter cube per second. So the volume with respect to time is 15 centimeter cube per second. Alright, that is the first one. Find the rate of increase in the radius when it is 10 centimeters. So I'm giving the radius as 10 centimeters. And I'm finding the rate of increase in the radius when it is what? 10 centimeters. So it means that since the volume is now increasing with respect to time, I'm also going to find the rate, actually the radius also increases with respect to the same time. So that one will be what? The R on the T. So take note, what I'm finding is the rate of increase in the radius with respect to time. So if I'm finding the R on the T, then what do? I'll find the rate of change in the radius with respect to the volume. So there is change the radius with the volume. Okay, so take note that anytime you are writing the chain rule, okay, the R here becomes the numerator here, and then the T here becomes the denominator in the second rate of change when you multiply. Alright, so since I'm finding the rate of change of radius with respect to time, then I'll find the radius, it should be the radius with respect to what? The volume. First one, it was the volume with respect to time. So that should be the volume should be the numerator. But here it is the radius with respect to time. So the radius should be the numerator. With respect to what? With respect to the volume. Alright. Then times, okay. Then you also find the volume. Also, it's respect to what? It's respect to time. So it is simple, so simple. So as I said, this and this will always be here. Okay, the R on it, and then your whatever you are considering here is in terms of volume. Okay, so that when I take this one, I have the R on the T. So I'm finding the radius with respect to time. So what I'll do is to find the radius with respect to the volume, the two. Then you find what? You find the volume also respect to what? To the time. Alright, so this is what you have. So if you're able to write the first one, then this one you should be able to write it. Okay, so we know the V on the T is what? Is the 15 centimeter cube per second. What is left is the R on the V. all right, the r on the v. So if I want to know the radius in terms of the volume, then I have to find what is the formula for the volume of what? A sphere. He's talking about a sphere. That is 4/3 pi r cubed. If that is the case, 4/3 pi r cubed, then my dv on the r. Okay, I'll differentiate v in respect to r. Alright. So my dv on the r. So 3 will come here. So it will be like 4/3 times 3. 3 will cancel 3. Alright. Then here we are left with 4. So I have 4 pi r. Subtract 1 from here. Square. So I'm going to have what? 4 pi r square. So that is the rate of change of v respect to r, 4 pi r square. However, here I'm supposed to multiply the radius, the rate of change of radius respect to volume, not volume respect to radius. So what I'm going to do is what? I'll find the reciprocal. So when I reciprocate, it becomes the r on the v. So the reciprocal of the r on the v will give me what? Will give me this particular result here. So if I have the v on the r, then to find the r on the v, I just have to what? I just have to reciprocate. Okay. So what here it means is that the r on the v will become 1/4 pi r square. 1 over. So this is how it will be. So when you reciprocate, you get your the r on the v, and then 1/4 pi r square. So here I can now find my the r on the t. So my the r on the t will be equal to, what is my the r on the v? 1/4 pi r square times my dv dt. Dv dt is what? 15. It's 15. All right. So I'm giving the r as what? As 10. So my the r on the t can be equal to what? 1/4 pi what? 10 squared. And then 15 times 1 give me 15. Okay, so that will become 15/4 pi 10 squared. That is the r. 1 times 15 is 50. Okay, so I have 15/4 pi multiplying 10 squared. The radius is 10. So this can be 15/4 pi times 10 squared. 4 times 10 squared. 10 squared is 100. So 4 times 100 is 400. So I can have 15 on 400 pi. But I can have something 15 on 400 pi. Alright, so what is 15 on 400? So 15 on 400 can be 3 on 80. Okay, so it can be 3 on 80. 80 pi, 3 on 80 pi. So if you like, you can write this as what? You can, let's substitute the value of pi there, and then we write our answer. If let's say pi is 22 on 7, then we can have for 3/80 times 22 on 7, and that will give us what? 0.0119 centimeter. So we are finding the rate of change in what? In radius, so centimeter per second. Centimeter per second. So our answer will be 0.0119 centimeter per second. Since it is the rate of change in radius respect to what? Respect to time. I know this is so simple to understand. Alright, I will see you again as we solve some past question on the rate of change. I know you have understood. We'll meet again. Enjoy your day. Bye bye.